So today's topic is stack, right? What is stack? We know that there is some LIFO and FIFO, right? LIFO. What is LIFO? Basically, this is last in first out, right? So stack is a linear data structure that follows the LIFO principle, that is last in first out, which means let's say we inserted 10, then 9, then 8, right? Now we need to take out the element. Which element will come out first? It will be 8, right? The last element which gets in will get out first, right? So last in first out, this is the principle. The last element added is the first one to be removed, right? Think of it like a stack of plates, like we are having plates, right? So you add to the top and remove from the top. Okay, that is stack, right? So some basic principles are operations: push, it will add the element on the top; pop, it will remove the element from the top; peek or top, it will basically see the top element without removing it. Correct? Is empty, this will check if stack is empty or not. So these are some basic operations. Now, where stack is applied? Let's see some real world scenarios. Browser history. There is one back navigation, right? We have like this and like this. So if you press this, you will get to the last open window, right? So that is stack. So the windows will stored in the stack and you will get the last opened, that means the last pushed. Okay, undo functionality in the editors, like the thing which you, let's say you have cleared something. Okay, you have written clear and then you removed it, then again you press undo, then it will show you again, right? So here also stack is using. Correct? Reversing a string, like in the reversing of the string we can use stack. Expression evaluation, let's say postfix or infix, right? So let's say we have expression a plus b, here it's plus, then a minus b. So we can use stack evaluating this expression, right? So this bracket is there, so stack will take care of this. Let's say instead of this plus we are having minus, right? So all of the sign will change, right, inside this bracket. After opening this, it will be minus a plus b. So here we can use stack. Call stack, basically this is the question asked in Google. Okay, this is very important and hard question. Call stack in programming languages. So yes, what are the coding problem use cases? Balanced parenthesis. In the interviews they usually ask this question, like we are given the parentheses, we need to find if they are balanced or not, right? So here we will be using stack. Correct? So we are opening this, then again we are opening, but we are closing, right? We are again opening this square braces, we are closing it, we are opening this, we are closing this, and we are closing this. So this is balanced. Got it? See, in the recursion we will use stack. If you see the recursion, how recursion works, let's say we are having like this tree, we started from here. Okay, in the stack we will put this element 1. Okay, 1, then it will go to 2, right? We will put 2, we will go to 3, we will put 3 in the stack. This is basically the backend. Okay, now 3 will be completed, right? The operation of 3 will be completed, it will go to 2, 3 will be completed, this is the stack. Then what is the next element? It's 2, then we will perform 2, right? So this is how stack works in recursion. Okay, so this is the use case of recursion. Now what is the next coding problem? Next greater element. Now here we will be using one term is there, that is what is the term? Here it is monotonic. Yeah, It's monotonic stack. Okay, so what is monotonic stack? See, we are having the stack in which we will be maintaining the order. Order is maintained. It can be increasing, it can be decreasing, it can be decreasing. Okay, let's see what is the decreasing order. Let's say we are having the element 10, then it will be decreased. Next element will be decreased 9, then 8, then 7. Okay, so this is what decreasing monotonic stack. Okay, so in the question like finding the next greater element, we will use this decreasing monotonic stack. How? We will check in the question. And what is increasing? Opposite of this. Let's say we are having 7, then 8, then 9, then 10. And this question, increasing monotonic stack will be used in the finding next smaller element. Okay, so these are the monotonic stacks. Order is maintained. Okay, after that, evaluating reverse polish notation. This is one of the question. Decode the string, backspace, string compare, histogram, remove key digits, monotonic stack problems. Okay, so these are some coding problems use cases. Now, when to think of using a stack in the problem. So we will check for the clues. What are the clues? If we are asked some like there is nested structure like this, okay, where we need to find the combination, right? In that we will be using stack. We will be pushing these let's say open, and we will be comparing with closing, right? At the end we will see if stack is empty or not. We will solve this question. Okay, balanced parenthesis. After that, if there is one, let's say, question in which functions are there, let's say undo, backtrack, or previous state, in that we should maintain the LIFO structure, right? The last in, that is the last in should be go first, correct? The LIFO structure should be maintained. Next, greater or the smaller element, monotonic stack, evaluate expression, this question, right? So in that also we will be using stack, back, space, reversal, trace previous elements. Okay, so the stack of the indices or the values. So how to apply the stack? It's simple. We will initialize the stack using this stack class. After that we will push the element using push function. Okay, and we need to mention this type also, integer, character, string, anything, right? And we will get the top element using dot peek method. It will get the top element. Okay, and we can remove the element by using pop method. After that we can check the stack if is it empty or not using as empty method, correct? So these are some basic operations or functions in problems. So these are the examples. After that, what are the benefits? It's simple and fast. Push and pop operation in O1 time complexity, right? After that, natural fit for recursion backtracking problems. Okay, as I mentioned this recursive example, right? This one. So in some question you may ask like recursion scenario will be there. In that question you should apply this stack. Okay, so backtracking, yes. Memory efficient, keeps only what's needed, LIFO. Easy to implement, this we only need to initialize this thing, right, to use. So these are some tips. Use monotonic stack for greater and the smallest element. Next, greater or smallest element. Use nested structure for reversal. Use stack of pairs, value and index for advanced use. Okay, so these are some tips, right? So shall we solve the first question, that is this braces We need to check if they are balanced or not. Okay, so the first question, this valid parenthesis, right? Let's see the example. Let's say this is the example. Okay, now what is the input given? The braces are there, right? The opening and the closing, the square opening, closing for that, the curly braces and closing for that. Now we need to check for balanced. What we need to check? Every opening braces should have its closed one. Okay, it's closed braces, right? So if you check this, do we have the closing for this? Yes, we have. If we check this, do we have closing for this? Yes, we have. If you check this, do we have closing for this? Correct, it's there, right? So let's take the example like this. Let's say we have this curly braces, this thing, the square braces and this. Now is this balanced or not? We have the opening bracket, right? We will store it somewhere. Let's say in the stack we have stored this, right? Now we will check for this. We will store, right? Again we will check for this, right? This is the closing one, right? So we will check in the stack, it's there or not. It's not there, so we can return false, right? False, correct. So what we will do, see, if we get the opening bracket, let's say if this is the bracket, then we will do what? We can either push this the opening or the closing bracket, right? Because we need to find the corresponding closing for this. So let's say we are pushing what? This closing for the corresponding opening bracket, right? So currently we are having this thing here, right? After that, let's say this is curly only. After that we are having what? Else if we are having this curly opening braces, right? We will push the corresponding closing bracket, right? We pushed this one. Otherwise, same with the third, right? Else if third one was the square braces, right? We will push the corresponding this thing, right? The corresponding closing bracket. After that now we will check if we will be having this now, correct? We pushed this one, now we are at this. Now we will check if the peak element is the same, right? Then we can pop this, right? So we will check else if the pop or the peak, anything we can write, right, is not equal to this. Let's say this is what? C. Okay, is not equal to C, then we can say return false. Return false, correct. Let's say we are having here the square braces. These both are not same, right? So match is not there, correct. In that case we will be returning false because they both are not same. Otherwise at the end we will return true. Got it? Yes, we can also add the function here only, like if stack is empty. At any case, if stack is empty or this is the case, if they are not equal, in that case we will return false. Okay, then let's write the code. We will be having stack of type character, right? Let's say stack equal to new stack, correct. Now what's next? We will be using for each loop for this string. We will be converting to char array, right? S dot to char array. Now if we are getting the opening bracket, we will push the corresponding closing bracket. If C is equal to this opening braces, then we will say stack dot push the closing braces for the same, right? And same thing we will do for the others, right? Else if it's the curly braces, we will do same. Else if this is the square braces, then we will do same thing, right? Else in the last condition, if they are not the opening, they are the closing braces, now we need to check in the stack, right? Before that we will check one condition. What? If stack is empty, or the character is not equal to stack dot pop. Okay, stack dot pop, the top element is not equal to the this closing braces, right? Not equal to C, that means we can return false. This is not balanced. Otherwise return true. Run this, compilation error, stack is empty. Acha, okay, I'm testing you guys. It's correct. Let's submit this. Wrong answer for 1. It's saying true and expected as false. So what is the issue? If stack is empty, right? Stack will be empty, and this is the opening bracket. We will be pushing the at the end. Yes. Now we can return stack as empty. Okay. The next question is next greater element. Okay, so in this what we will be using the next greater element? Anyone? With answer can you also teach the time and space complexity? Why not? Just a minute. See here, what is the time complexity? What we are doing? We are traversing this string, right? We are traversing the each character of this string. Only this loop is there, so it will take of n time complexity, correct? Nothing else is there, so on is the time complexity, and space will be, it will be of n only, right? It will be basically O n by 2, but in the worst case it will be O n. Got it? Sumit? Okay, so in this question, let's see the question. So we are given the basically two arrays are given, nums1, nums2, where nums1 is the subset of nums2. Okay, find the index j such that nums1 I is equal to nums2 of j, and determine the next greater element of nums2 j. Okay, so let me explain you what we need to do here. See, we are given two arrays, nums1, that is 4, 1 and 2, nums2 is 1, 3, 4, 2, and we are given this nums1 as the subset of this nums2, means each and every element of this will be present in nums2. Okay, so we need to find the we need to check each element from this and find the next greater element for these elements in this array. Got it? So basically we need to find the next greater element of 4, right, for 1, for 2 from this array, right? For 4 it will be what? It nothing is there, right? Next greater element, nothing is there, so it will be -1. For 1 it will be 3, right? So 3 will be there. For 2 nothing is there, right? So -1. So we need to return -1, 3 and -1. How can we do this? See, we will find the next greater element for all the elements from nums 2, right? First step is this one. We will find all the next greater element for all the elements in nums 2. After that, what is the second step? Second step is we will store this those values in some map. Let's say next greater element of each element in map, right? The next step will be we will traverse this nums1, get the value from this map and print it or return it, right? So we will check for 4, 1 and 2. We will get the next greater element from this map. So understood this approach, these steps, 3 steps. First we will find the next greater elements for all the elements in nums2. After that we will map each element with their next greater element in the hash map, right? After that we will traverse this nums1 and find the value of each element, that is the next greater element. Now the question is how we will find this next greater element. What is the brute force approach? Let's say we are given the array. What was the array? 1 3 4 2. 1 3 4 2. What is the brute force approach? Let's say we need to find the next greater element for 1, for 3, for 4 or 2. How can we do this? Using 2 loops, correct? We can use the nested loops. We will start from here. We will again start a loop and check all the elements which is the first greater. That means this is the next greater element, right? But this will take O(n) square time complexity. We need to optimize this. We need to make it O(n). How can we do this? Here we will be using monotonic stack. Okay. For next greater element we will be using decreasing stack. Okay. How? See, let's say this is the array given, right? Let's maintain a stack. Okay. So we will start from the starting point. 1. We can push 1, right? Now we will go to next element 3. Now we will check. We will check with this element. 3 is greater. Yes, 3 is greater. So we can write 3 is the next greater element for this num, right? The last key, that is 1, right? So we can write for 1 it will be 3, right? The next greater element. Let's write it here. It's 3. Okay, NGE. After that we will do what? We will pop this. We will pop this and insert this 3. Okay. Now 4 will come, right? Again it will check for 3. 4 is greater, right? So the next greater element is 4. We will pop this. We will insert what? 4 here, right? It will go to 2. Now 2 is the greater element or not? It's not, right? So we can simply insert 2 here. We will not pop this out. Let's say we are having one more element. Let's say 6, right? So let's write the greater element. We pop this one and the next greater element, that is the value is 3. For 3 it will be 4. For 4 we need to find. That's why we didn't pop this out, right? Now 6 is there. So we will check this 2. 6 is greater. Yes, it's greater. So the value for this it's 6, right? So it will be 6. We will pop this out. Again it will check with 4. 6 is greater. Yes, it's greater. So the next greater element will be 6. Okay, so we will pop this out. At the last 6 will be there, right? So we will get this numbers. At the last we will check all the elements in the stack, the remaining elements, and the value for that will be -1. Okay, understood the approach? We are maintaining the decreasing, sorry, not here. If you see, like before 6 it was 4 and 2, right? So what we are maintaining, this is the decreasing monotonic stack, right? So we need to maintain this. Now if the question is we need to find what? The next smaller element. In that case we will be maintaining the increasing stack. Okay, so we will do the opposite. Here we are finding the greater element, there we will be finding the next smaller element, right? Everything will be same, just we need to change the sign. Okay, let's code then. So let's make the stack first with type integer, stack equal to new stack, right? So after that we will be having one hash map, right? Hash map for storing the values of this nums2. It will be, the key will be integer, the value will also be integer, right? Let's say map equal to new hash map, right? Now we need to return the result, right? So result of this size. So let's make this also int result new int of size nums 1 dot length, right? Now what we need to do, we will traverse this nums2, right? Int num of nums2. Okay, now what is the first condition? See here what we are checking, if you see this example 2 and 4, what we are checking, if this element, the peak element, is not greater, it's smaller than the current element, then we need to remove this, right? So first, while condition will be there, within while the stack should not be empty, and the second condition is the num, that is the peak, the current element, if this is greater than the peak element, stack dot peak, right? The topmost element, that means this is the next greater element for this peak element, right? If you see this, we removed, we compared this 2 with 6, and this is this 6 is greater, that means for 2 the next greater element is 6, right? This is current element, that is num, this is peak element, right? So we will store this part in the hash map. So map dot put what, stack dot pop, right, the topmost element, and the value will be num, right, the next greater element. After that, in the stack we need to push that element, right? Stack dot push num. Okay, so basically first it will compare with 2, right? It's greater, it will push this into the map, then it's a while loop, it will come to 4. For 4 it will push this, right? So we pushed the basically the element with their next greater element, right? So if they in the interview they gave only this one array, then this is enough. Okay, after that we just need to return the values. Got it? So let me write it. This is for finding the next greater element for each element in nums2. After that, some elements will be there in the stack, right? So for that, the value will be what? -1, right? If it's not empty, then we can put map dot put stack dot pop with value -1. Got it? So this part is enough if they give you only one array and we need to return the next greater element for each element. But here we need to find the for these elements, right? So we need to find it from this map. Okay, so what is the next part then? We stored this answer for each element in the hash map. Now we just need to go through this nums1 and find the next greater element, right? So for loop int I equal to 0, I less than nums1 dot length and I plus plus, right? And thus res I will be what? Map dot get what we need to get? Nums of I, right? So we will get the next greater element for this element, right? That's it. At the end we will return res. Got it? Let's run this. Compilation error dot get nums of I nums1. Accepted. Let's submit this. It's accepted. Now what is the time complexity for this? Anyone? First of all, understood everyone what we are doing here? This is the code. Here basically finding a next greater element for elements in nums1 from above map. Okay, basically nums2, because they both are subset and we need to find the next greater element from this nums2 only, right? This is the code. What is the time complexity? We can consider this as constant, okay, because overall it will be on only. If you combine this also, it will be on, and after that n is the length of this nums2, and for this loop it will be of m. So overall it will be n plus n. Okay, what is the space? Okay, space will be, we are using stack, it will take what? In the verse it can take O of m, right? Hash map will take of n, correct? So overall it will be same, n plus n, if we remove the constant. Okay, then let's move to the next question. Simplify path. Okay, so you are given an absolute path for a Unix style file system. Now who has used Linux? There is some we need to go to directories like cd/home/fo, right? So basically what we are given? We are given some kind of incorrect and we need to transform it to this absolute path into the simplified. Okay, let's see the example. Let's check this one. And there are some rules. Rules are the path must start with single slash, directories with the path must be separated with 1/, the path must not end with slash. Got it? After that, the path must not have any single or the double periods. Okay, and this double dot used to denote the current or the parent directory. Okay, and for example T are valid directories for the file names. Okay, zero used to current or the parent directories. Okay, so what are the rules? Basically we are given this path, right? Slash home user document, after that these two dots, right? But we need to remove this dots. What does two dots means? Means the parent directory, right? Means the previous directory, so it will go to the previous one, right? So after the basically the operation, it will be home user, then this it will go to the parent directory, that means users, right? So document will not be there and pictures, right? So these are some rules. We need to start with slash directories separated with slash, right? And what else? Must not end with a slash, and single must not have any single or the double periods. Okay, so basically see how we will do. If two dots is there, then we need to remove the last directory, right? We will remove document, correct? Now how can we do this? We will be, this is the string given, right? First we will make an array by splitting this with slash, right? We will get home user document double dot and picture, right? Now if we got this double dot, we need to remove the last one. How can we do this? We will be using stack, right? We will be using stack. We will check if there are some conditions, right? Dot should not be there, or let's first write the condition for this. If we got let's say s is equal to dot or anything or like empty string, then what we will do? We can simply continue, right? We can simply continue. After that, what is the next condition? If double dot is there, right, then we need to remove the last directory from the stack, correct? If s is equal to double dot, then remove from the stack, so stack dot pop, correct? Otherwise we can simply push the element in the stack. So we will push home, then user, then document, then double dot will come, it will remove document, then pictures, right? Correct? So now we will traverse this and add in the string. So now the principle is LIFO, right? So it will be like picture, then user, then home, right? Like this we will get. Can we get in the insertion order, like first home, user and picture from the stack? Let's say we are using for each loop, string directory stack, right? So it will print in the insertion order, not in the LIFO, this is main point. Okay, we will use for each loop in the last. Okay, so let's code it down. So initially stack will be there, stack string, right? Let's say stack equal to new stack, right? After that we will convert this the given string into the string array, string arr, or let's say components. Okay, it will be new int, sorry, not int, not new, it will be path dot split, right? Split using the slash. After that we will be using for each loop from for this components, string component components. Okay, we will apply for each loop on this components. Then there are some conditions, right? What are the conditions? First we are checking this dot or empty string, right? Let's say in the question we are having what? We are having 2 backslash, right? 2 backslash are there. Then what we will get after splitting with this this slash? We will get empty string, right? That's what we are checking here. So condition is there, component dot equals what we need to empty string, and the second condition was f dot is there, single dot, right? Then what we need to do, we need to continue, right? We need to ignore these empty string or single dot. After that, the second condition is if component dot equal double dots, right? Now we are not using if else. If we will use if else, then it will not come to this condition. What is the condition we need to check? If stack is not empty, then we need to pop this last directory, right? Stack dot pop. Then what else we can simply push the element, that is the component, right? Got it. Now we need to check if stack is empty. If our stack is empty, let's say we are having this scenario, home, okay, home, then double dot, right? This is given, let's say. Now what is the result? What is the simplified version of this? It will be single slash only, right? So our stack will be empty, correct? So we can say if stack is empty, we just return this slash. That means this is the root, right? Correct. Otherwise we need to store this stack elements into some string. So let's make string builder. The elements, these are the elements, right? Home, user and picture, right? So we need to store them in some string. So string builder. Why we are using string builder, not string? Because at every point string will create a new object when we will add something in that, but string builder will use the same object. At the last we will convert this string builder into string. For loop will be there, and string dir stack, right? Now what we need to do, we need to insert a slash before the directory, right? So result dot append what? First the slash, after that this element, dot append what? Dir, correct? At the last we will return this result to string. Let's run this. Accepted. Let's submit this. It's accepted. What is the time complexity here? On is the time complexity. We are having this for loop. That's it. So there are some questions you need to solve. First, try to solve this for monotonic stack, right? The find smaller element. Okay, this question you need to solve it by yourself, and rest, these are the questions